Hello and welcome to Module 6. In Module 6, we'll be talking about developing that declarative knowledge for our students. In the previous two modules, we talked a great deal about conceptual and procedural knowledge, and as you know, as teachers, we must do our job to develop that declarative knowledge as well in mathematics. Declarative knowledge refers to information that students retrieve from memory without hesitation. It's all about the automaticity. Instructional activities that we design to build declarative knowledge typically occur after conceptual understanding of the skill has been developed and after related procedural strategies have been taught. I know that's a little backwards, maybe from your own experience. I know mine personally, it wasn't set up that way. It wasn't that here's the concept, here's how we solve problems, here's why we set it up this way, and now let's work on the facts. I was always taught we need to have the facts first and foremost, so that way you can understand how you set up the problem and use those facts in your problem and forget basically about that conceptual knowledge. At least that was my own background. The rationale for why we really have to develop that declarative knowledge is because it is so necessary for our students to be able to develop a strong mathematical competency. It helps our students to experience that success while they progress through the mathematics curriculum. The ability to memorize and quickly retrieve memorized information is so important due to math being so in a hierarchy. It's so important that we realize that it builds upon itself, and so we have to do our job to build as it goes. Declarative knowledge is also so important in terms of maintaining math skills and generalizing math skills from both their school environment and also outside of their school environment. So let's just go ahead and jump into some questions. The first question that is listed here is talking about what are effective approaches to building math facts, functional math skills, and number sense. The chapter in Hudson and Miller talked about this a great deal and kind of broke them down into different sections, which of course I know you have already read, so I'm kind of reiterating things that you have read from last week. But the memorization of basic math facts is key. Researchers have noted that weak recall in basic math facts is one of the most common characteristics among students who have such difficulty with math, and that's so true. Researchers also agree that weak recall of basic facts negatively influences students' ability to succeed in subsequent mathematical skills. So clearly, because of the hierarchy that it is, if they don't build upon it and now, they're only going to have more issues later. A key thing that we have to keep in mind is that the human mind, whether we have a student with cognitive difficulties or not, all humans have only a limited capacity to process information at the same time. So you're only given so much that you can work with at a time. And so as students, if they are so bombarded or spending a significant amount of cognitive effort just figuring out multiplication, they're going to have much more difficulty with solving a problem or having multiple steps in a problem and keeping it all straight. That declarative knowledge relates to just basic facts, reduces that burden that students are placed with, and really helps them to prevent the domino effect related to mathematical failure and subsequent skills such as multi-digit addition, subtraction, multiplication, long division, fractions, decimals, percents, and I could go on. There is a huge correlation between math fact fluencies and students being successful, obviously. Now, I know you might be asking yourself, well, what happens with our students who have memory issues? How is this even fair to them? Well, my answer to that is it's not fair to them whatsoever, but it's also not fair that we just use that as a crutch and say, well, it's okay, they just don't have the memory, so therefore they just don't need to do this. Absolutely not, because it's one of those things that we can give them tools and we can give them things to help them to be successful, such as giving them a calculator, a multiplication card, etc., while they're trying to learn these things. But that doesn't mean that we just don't address declarative knowledge at all just because the memory issue is there. I know it is very difficult. There are hundreds and hundreds of facts for our students to memorize, and I would not ask my students to have to do the task of memorizing 0 times 1, 0 times 2, 0 times 3, 0 times 4, etc. That's why for every student we give them, well, anything that's times by 0 is going to be 0, or anything times by 1 is going to be that number. There are ways that we can help our students feel success even if they're not relying heavily on their memory, just because they could practice one rule and apply it to a multiple problems. The next part that the book talked about was that math fact knowledge must be not only quick, it can't just come to them very quickly, that it also has to be so accurate and to be able to be generalized to different tasks both in and out of school. Where does this all come from and how do we make that happen? Effective instruction. It goes back to making sure that we are doing the right thing in the classroom to build those skills. And we'll talk about some strategies in just a moment. Number sense is huge because that's all about the fluidity and the flexibility with numbers, having the sense of what numbers and the ability to perform mental mathematics and not to, in order to make those real world connections. Functional skills, of course, are our everyday activities, whether it's interacting with money, time, or measurements. So, as you can see, declarative knowledge really impacts multiple areas of math. How can these strategies be implemented in Tier 1 and Tier 2? Well, as you remember, Tier 1 is the whole class, so clearly there's a lot of fun activities that you can do in a whole classroom, or even Tier 2 is doing it within a small group. I look at elementary as being much easier to do a lot of these activities in a whole group Tier 1 type of setting. Once you get up into middle school or high school, clearly a lot of those facts in the whole classroom sure to be in place. So maybe the Tier 2 interventions of having some small group activities might be more appropriate. I'll be very honest with you, I've worked with a lot of seniors not even on IEPs who still struggle with basic facts. And so it's just a matter of a process of helping them develop that declarative knowledge. So you might be asking yourself, what are the effective strategies for teaching this then? What do we need to do? Well, before we get to that part, I want to go over some of the guidelines that Hudson and Miller addressed in the book. There was a huge emphasis within the book, and I truly back and support their research and what they found, that there needs to be a huge emphasis on practice opportunities, but these practice opportunities can't just be dull and boring that the kids are not going to get anything out of it. It has to be a high quality practice activity where they're highly engaged is the key. If they're not engaged in it, forget it. They've got to have some buy-in to why I need to do this. I know for me as a student, I was a very competitive student. Well, certainly all students are not competitive, but for me, we had relay races in the classroom to memorize facts and to compete against boys versus girls, or this side of the room versus that side of the room, or those who are wearing blue shirts versus white shirts, or whatever it may be. We were broken up into different groups and we competed against each other. I will be very honest, when I first started, I didn't have my facts memorized, and so I was always the first one to be out of the game. And that was sad to me. I felt very bad about myself. I felt very bad that I didn't know what I needed to know. But did that motivate me to learn my facts? Absolutely. I went home that day and went and practiced with my family or whoever I could to work on these facts. So the next time that the teacher provided that opportunity, I wanted to win. I wanted to be the one who knew all of my facts and could stay in the competition as long as possible. So that worked for me. It might not work for others, but that level of competition certainly sparked my interest and it certainly got me on board. That might work for some students. It might not work for everybody, but there's no harm in doing maybe a small group for students who you can see have that competitive nature to memorize their facts. We always want to make sure we also assess our students and using those curriculum-based assessments, CBAs or CBMs, to check to see what their knowledge already is. That way we're appropriately instructing them correctly on what they need for their declarative knowledge. This includes those time tasks. Once again, I know time is hard, but that shows what their fluency looks like in regards to being able to recall those facts rather quickly. So using those as a starting point is key, and then it doesn't make sense for them to practice facts that they already have maintained or mastered. It's only focusing on the things that they need. I know when I was in school, everybody had to do zeros, ones, twos, threes, etc., all the way up from addition to division. It's clearly not needed for students who could quickly test out of those things, as that just becomes dull and boring. We have to select various modes of practice. We've got to make sure that whatever we're picking, that we kind of mix it up and change it up for our students. And maybe this week we do a competitive activity, next time we do more of a hands-on activity, next time we do a musical activity with it, or next time we do a kinetic activity with it. Whatever it seems that might work for your students, we need to mix it up. Encourage students to take the risk that it's okay to be wrong. That's the way we're going to learn, and to really encourage them and reward them when they rely on their memory rather than sitting there counting their fingers. Encouraging them that it's okay to do that, but really when they take the opportunity to have those mental successes, celebrate those things. You want to really set them up for success. And we should also, a huge effective piece of this and an effective approach is when we're working with students to build this declarative knowledge, we can't just be like, I need you to memorize every single multiplication fact from 1 to 12. etc. You can't do that to a student. We have got to break it down and chunk it separately. Start with the easier things first and then build from there. The hardest thing in multiplications is going to be your sixes, sevens, eights, and nines, and 12s. Those are basically the ones that are more challenging. Those should be on the other end, not at the beginning end of starting to memorize multiplication facts. So, now that we've talked about those guidelines, there are a variety of instructional interventions that teachers can use and strategies to help students develop this declarative knowledge in math. Included among these, and the book talked about these in much more detail than I'm going to cover today, but it's the constant time delay, prompt fading procedure, 1-minute timing, instructional games, 3-step labeling procedure, and computer-based instruction. All of those are great strategies to help students build that knowledge. What are some authentic examples of declarative knowledge in school, daily life, work, and leisure? I think it's really important, as we've talked on the other two modules, that I always feel that it's important to help kids to understand what the point is, or the relevance to having them learn these things. Why is it easier to come up with these things rather quickly? Well, when you're doing things such as planning a party, breaking into equal groups for projects, maybe doubling a recipe, it's a lot easier to have this declarative knowledge come at more an automatic rate than having to take more steps than needed when you're doing these bigger tasks, or not so bigger tasks, depending upon what you're doing. Within Blackboard, I have given you a list of websites that can aid with math facts. Feel free to review this and keep it for your future reference. There's a ton out there. There's obviously more manipulatives that you could check out even within the curriculum lab, or even find or make yourself. The biggest thing I think for us as teachers is that we want to find something that's going to engage our students to really be successful. This is not exactly what I was looking for, but I try to find the best picture I can. I know within, I believe it is the Saxon curriculum, they have ladders that you tie up and you do your facts quickly, and you it's a multiplication ladders. I can't even think what they're called off the top of my head, but I know that you could even purchase them at like Teacher's Pet or other places that have teacher supply things, where they're easy sets that you can hand out to students and have them practice, even if it's for the first few minutes of class, or have them pull out their whiteboards and start practicing problems that they don't remember, or using flashcards, or making it fun interactive flashcards, or like this little pad down here where they could jump on different parts and then say whether they're going to multiply or subtract or divide or whatever it may be. In addition, it could be as simple as rolling the dice and setting up two numbers and multiplying the numbers with each other and moving around a game board, and whoever gets there wins. Whatever it may be. I think the point is to choose something that you know is going to work for your specific students, and there's tons and tons out there at your fingertips to help your students. And some of the things that are out there now are even cool because they're fun interactive games that even I as an adult enjoy playing against my students, just to help them with developing their skills. So I hope that gives you information enough that you understand this concept. If you have any questions, as always, let me know. I want to reiterate again, not to nag, but definitely be making sure that you're following your graduate project timeline, and that you're continuing to work on your project as well as your math project in addition. And a lot of you have been asking some really great questions, which I appreciate. And last but not least is, again, if you have any other questions or need any other help for this week, as always, please let me know. I hope you have a great week. Take care.